All right. So when we're dealing with periodic functions, we're often dealing with angles, and there's some very important conventions for dealing with angles. Okay. One of the first one of those conventions is that angles are measured from the positive x-axis. So the positive x-axis is here, right? It's the positive x-axis. And so when we measure angles, we're going to be measuring angles on a unit circle pretty soon here, but we're always measuring them from the positive x-axis. Okay, so you can see this 90 degrees is measured from the positive x-axis. Angles are also measured in the counterclockwise direction. So positive angles are in the counterclockwise direction, and negative angles then would be the opposite of that, in the clockwise direction. All right, so just remember, positive is counterclockwise, negative is clockwise. Okay, so here's an example of a negative angle. Negative 90 degrees means it's measured in the clockwise direction from the positive x-axis. Okay, so all right, so that's the next convention. Also, large angles wrap around the circle more than once. So you can see, here we're at 90, here we're at 180, here we're at 270, here we're at 360, but we can keep going, right? If I go another, go another 90 degrees, right? 360 plus 90, okay? So now I'm at what? That 360 plus 90, that'd be 450, right? And, then I can go another 90 degrees, right? I'm at 540. And then another 90 degrees, right? Another 90 degrees, and I'm at 630, right? Another 90 degrees, and I'm at 720, okay? So, so we can just keep going, right? We can keep going around and around and around, right? Just like the Ferris wheel. We can go around and around and around, and we can, then the angles can just keep getting larger, okay? Now we can also go in the negative direction as well, and we can wrap around the circle more than once there too. All right, so let's take a look at example 2. This says, given these conventions, evaluate the angles of the Ferris wheel at each time period in example 1. So we need to go back to example 1. Let's go back to example 1, way back here, and let's take a look at what are these angles. Right now we're measuring. Now in this case, our axis was time, right? But according to the convention, if I had the angle theta at that given time, right? I'm down here at the bottom. Well, if I put my positive x-axis here, right? I should scroll up with this a little bit so you can see more of it. I could call this my positive x-axis right through the middle here. Whoops. And you can see that if I measured that angle, I can measure it a couple different ways. It could be minus 90 degrees, or it could be positive 270 degrees, depending on how I measure it. All right. I'm actually just going to start at negative 90. All right. Let's start at negative 90, and then and go from there. All right. So at 15 seconds, now we're at the x-axis, so where I'm calling the x-axis. So so we're at 0, and then at 30, we're at the top of the Ferris wheel. All right, so that's a positive 90, right, if I measure it from the x-axis. And then we could just keep going around. So when we are over here at 45 seconds, we were at 180 degrees. Okay, it should all be degrees. At 60 seconds, we're back at 0, but we could call that also 270, right, at this point, because we've gone around the circle. So we're just adding 90 degrees every 15 seconds. So we're traveling 90 degrees every 15 seconds. All right, so we'll just keep going. So we have 360, we have 450, we have 540, again, all degrees. And then finally 630. And if we kept going around, we'd be at 720 and so on. All right, so that takes care of that example. While we're at it, let's take a look at the next one too, just because it's sort of related to this. Now, this example came to mind because felt like we needed to make that transition between, here we have this function for the height, your height above the ground as you ride the Ferris wheel, and we're measuring it with respect to time, but oftentimes we need to convert that to an angle, right? And so, and usually a Ferris wheel would move at a constant angular velocity, right? And then the angle would be a linear function of time. So angular velocity is essentially, can sometimes call it omega, but it's just the change in the angle over the change in time. All right, so we're moving 90 degrees every 15 seconds. Okay, so our angular velocity is 6 degrees per second. Okay. The second part just asks, what is the initial angle? Okay, we decided to call that we'll call it theta 0 because we're at 0, time t equals 0, right? We decided to call that minus 90 degrees, right? We're down at the bottom. We can measure it from if we put an x-axis straight through the middle of this Ferris wheel, we would measure, if we measure from the positive x-axis, that would be negative 90, okay? So we can actually write a function for theta with respect to time, right? And then we would get 6t minus 90 degrees. All right. Well, I'll meet you in the next video.